Hello, hello, hello. How is everybody doing today? Good old Tuesday here at school. We had a pretty good day, but super excited to teach. What we're going to be talking about today is dimensional analysis. Okay, we're gonna analyze different dimensions and convert them. Okay, and one of my favorite things, favorite examples to use is how many seconds are in a day. All right, and without looking, uh, I like to play a song, and you can almost Google that in the song. I don't think I can play a song through Screencast-O-Matic is what I'm using, but it's 86,400 seconds in a day to turn it all around or throw it all away. So that's the song lyrics, and I'm going to show you how they actually get to that number. Okay, so if hopefully you can see. Let me see if I can make that work. Okay, so hopefully you can see my screen here. I'm going to zoom in a little bit. All right, so here's my piece of paper. Now, how many seconds are in a day was the question. So I'm going to start off with one day. Okay, and my final goal is to get to seconds. I'm going to write seconds over here. Okay, that's my final goal, is to get to seconds. So what I have to do is create a railroad track. How's that railroad track look? Pretty good? All right. Now, since I have days on top, I have to put days on bottom. All right. And I have to use a factor. So I'm going to use 1 day. Now I have to use something that gets me closer to seconds. I'm going to use hours because I know how many hours are in a day, 24. All right. So 24 hours are in 1 day. And since I use day on top and day on bottom, those two cancel. Okay. Now I'm left with hours. If I have hours on top, I have to put hours on the bottom. So 1 hour. And I'm going to use minutes. Okay. I have 60 minutes. Since I have hours on top, hours on bottom, those cancel. And I'm super close to seconds. I have one more step. So I have minutes on top, minutes on the bottom. Okay. So, and I'm going to put seconds on top. So I have 60 seconds in 1 minute, and my minutes cancel. Okay, so all my units canceled except for seconds, and that is what I was working towards. Okay, the last goal is I have to multiply every number on the top. I have to multiply every number on the top. And you can use a calculator. So 1 times 24 times 60 is equal to 86,400. And now you multiply everything on the bottom. 1 times 1 times 1, which is just 1. All right? And you divide those two. So you do 86,400 divided by 1, which is 86,400 seconds. Okay? That's your answer. So that's dimensional analysis. All right? Now, you don't have to give me an example, all right? But I want you to try something for me, all right? I want you to try something. And it's a little weird, but step 1, I want you to measure something without using a ruler, okay? It sounds really weird, but I want you to measure something. It can be something as using a pen to measure the length of your computer. It could be something as easy as that. It could be using your shoe to measure the length of your room. Okay. So I want you to do that. Step 1, try doing something like that. What I did today was I measured my table using markers. Okay. And I'm going to give you an example of that here. So I measured one table. Okay. Oh, let me see what we got. So I measured one table, and it was 14 markers long. So since I have tables on top, I have to put table on the bottom. So one table was 14, I think it was about 14 and a half markers. Okay. So that's step one. Okay. So if you need to pause the video, you can. Step two, what I want you to do is measure what you measured. So I used markers. So I'm going to see how long a marker is. Okay. I'm going to see how long a marker is. My markers were 5.5 inches for every one marker. So if you used a pencil, measure your pencil. Or if you used your shoe, measure your shoe. All right. Now, from here you do dimensional analysis. Table canceled table, markers canceled markers. I'm left with inches. Once again, I multiply everything on the top. All right. So I get 14.5 times 5.5. It's going to be, I don't know. Let me plug it in my calculator here. 79.75. So that's the third step. Okay. Now, that is my guess to how long my table is. Do I really think my table is that long? Well, we'll have to find out. Okay. And measure it. So if you measured the length of your computer, look and measure how long your computer is. See how close you were. Okay. Like I said, you're not submitting this, but I do want to know like how well you guys did. Okay. So if you need to pause the video, you can. Okay, so that's dimensional analysis. Okay, converting units to units, and I'm gonna give a little bit longer of a video for this tomorrow, but that's introduction. All right. The next thing I want to talk about is metric conversions. Okay, metric is pretty straightforward, and I'm going to write some examples on my piece of paper for ways that you can remember metric. All right, there's a lot of ways we're going to use metric, and it's very important to know them. Okay, so you can see my paper. I'm just going to write on the bottom of this. There's a saying I always like to remember. All right, and that saying is King Henry doesn't usually drink chocolate milk. King Henry doesn't usually drink chocolate milk. Okay, it's an odd saying, but it's very effective. Okay, because what happens here is the K stands for kilo, the H stands for hecto, the D stands for deca, the U is my units. All right, my units can be either meters, grams, liters, etc. The D stands for deci, centi, and milli. Okay, that's what all of those stand for. Okay, and how this works is you can do different conversions. So let's say my favorite number is 4. Okay, I like the number 4. So let's say I have 4 deciliters. I'm going to start at deciliters, and my goal is to see how many hectoliters that is. Well, I'm going to show you a shortcut. Okay, and the shortcut to solving this is if I'm at decimeters, I'm going to move to the left 1, 2, 3 spots to get to hecto. Do you guys see that? If I start at deci, I moved 1, 2, 3. So 4, if I'm looking at 4, there's actually a decimal point after 4, correct? It's not before because that would change the number. So it's after 4. I'm going to move over the 1, 2, 3 spots, and I'm going to put my decimal there. And to fill in these gaps, I have to put in zeros. So my new answer is 0.004 hectometers. And that's how you solve using metrics. Okay. That's how you solve using metrics. I hope that kind of makes sense. So yeah, if you guys have any questions, let me know about that. For today, as long as you guys took these notes, I have one question that I want you to solve. I am not collecting it, but I do want you guys to try it out. I do want you to try it out. And the question is, which is crazy. The answer is crazy. We measured it out. And Usain Bolt, all right, Usain Bolt, the fastest runner in the world, he ran 27.8 miles per hour, I'm pretty sure it was. So I'm going to write it out, all right? He ran 27.8 miles per hour, okay? There it is. What I want you guys to do is I want you to try to solve that in feet per second, okay? Feet per second, all right? Try your best. Try your best. And I'm interested to see how you guys do, okay? And if you got this far in the video. So shoot me an answer. If you work it out, and take a picture of it and email it to me, all right? So I know that you guys are keeping up, and try it out, okay? One suggestion I will tell you is there are 5,280 feet in 1 mile, okay? So you're gonna have to change miles to feet and hours to seconds, okay? Try it out, all right? I'll go over this answer tomorrow. But if there are not any questions, like I said, I want you guys to work it out, take a picture of your work, and email it to me, okay? Yeah, if you have any questions, send that in the email as well. But we will go over more about dimensional analysis tomorrow, okay? All right. If there are not any questions, I hope you guys have a great day, and we will see you tomorrow, all right?